Welcome to this session of AKS Best Practice webinar. Today's subject is on monitoring and logging. My name is Dennis Zielke. I'm part of the Cloud Native Architecture team and gonna help you guide today through this subject. Let's give a little bit of intro of what we're going to talk about, and actually want to introduce kind of a little bit the problem that we're trying to solve of logging and monitoring. I'm going to introduce the Azure native solution that is available to you in Azure. I'm going to demo this hands-on with a couple of topical use cases and give you resources for following up and implementing this in your own infrastructure. Yeah, what is a problem at all? So think about how containerized applications are a little bit different than traditional on-prem applications. If you're having written log files, you can typically not go through log files on containerized environments in your cluster. You know, from the process problem up to the technical ones, you need a different way. In that sense, you typically ship the logs that are written on standard out and error to somewhere place else for later on indexing, searching, and aggregation, and maybe even persisting for longer times. Which is kind of the problem, kind of what has happened in my application. How can I figure out if a user or problem seems to have occurred, go through log files, figuring and narrowing down the time frame and understanding the problem, and then giving that to an option to fixing that. The other thing that you typically have is kind of that you want to monitor the application at runtime, thereby observing the metrics that your system is exhibiting, starting by the underlying infrastructure and the cluster. So having different nodes in the cluster that have kind of key metrics like usage, memory of disks, and networking that are being obviously also available on the underlying level, which is for pods in different namespaces, for sets of pods that are surfacing certain metrics that you want to have an observation, down to underlying base metrics on the networking and file level across different environments. Thinking about that, this is the bigger problem that you want to solve. How do I get logs efficiently? How do I have an observation on metrics at runtime at any point for different roles, environments, and applications? Entering the problem, now the solution. Azure Monitor is kind of our first-party solution that is available in Azure. You can activate it very simply for containerized environments, specifically Kubernetes in this case, and make use of that. The typical problems that we're trying to solve here is kind of starting with a simple one: is my cluster healthy? Coming from the infrastructure perspective, you have a set of environments. You want to know, understand that everything is good on a simple view. The other part that you want to go is have some sort of troubleshooting guide to, if a problem seems to be occurring, how do you diagnose and drill down efficiently on the problem, and give people that might not that be familiar with how the environment is typically run, kind of think about average developers, an easy way and how they can get down to the problem without kind of directly connecting them to the machines. You want to have this at a very low maintenance overhead, so meaning running your own logging and monitoring infrastructure can consume, again, additional costs in terms of personnel and infrastructure. You want to keep that very low, which is kind of the design point here. And you want to have the experience of bringing that into a running environment as small as possible. So how does it look like in practice? Think about your average Azure environment. You have a set of clusters running in this in a set of subscriptions. As you can see here, I have 3 clusters in set of subscriptions. 2 of them are monitored by Azure Monitor, which is sort of the entry view onto all of my environments. And there's additional environment, as you can see here, but which is sort of being detected but not really monitored. I can bring it up into the Azure Monitor as well, Since in this case, this is pure Kubernetes infrastructure based. I'm going to show you how this can be done later. But for the moment, we want to start with the Azure managed Kubernetes versions. You can see there are two clusters sort of running, and one of them seems to be having a problem. As you can see, the cluster is, from the infrastructure perspective, running 4 nodes. All of them seem to be fine. The system pods are also running fine, so the base Kubernetes is also all right. But in the user space, meaning my own application, there seems to be something wrong, as kind of only half of the pods are actually healthy and running, which might be something relevant to drill down and look into. But the good news is there seems to be another high-value business application that is running on a smaller cluster, which doesn't have any problems neither in the kube system pods or in the running application pods. Being alerted to the issue, kind of we naturally start by going a little bit deeper into the cluster that seems to be having problems, which is in this case our dev environment. The whole point here is that this is a managed Kubernetes cluster, and it comes sort of out of the box with the managed version of Azure Monitor included. First of all, we start again with the high-level view. What you see here is sort of the cluster overview. You see there's a set of nodes running in this cluster. In this case, there seem to be 5 nodes. There seem to be some scale operations going on for some reason, as the cluster size has increased from 2 to 5 in the last hour. And change the time frame a little bit to get a sharper view on what's happening here. The assumption would probably be that there's some sort of autoscaler running, as the number of pods has also increased, and with the number of pods being increasing, the number of nodes naturally follows that, in sense if you have an autoscaler rule activated. But that alone doesn't seem to be troublesome. So you can see because of the node memory utilization seems to be fairly okay, and the CPU utilization seems to be fine as well. In the pending space, you can see here now that the users or developers seem to have requested scheduling of a number of pods inside this cluster, which have been in the pending state for quite a while, until the cluster size and the left-hand side has been increased to accommodate that need. And now we're kind of in this space happy because all the pods seem to be running. There's nothing pending and there is nothing unusual. So that being a good sign, let's go a little bit deeper into what is happening here. The next phase is about kind of having looked at the cluster. Now want to take a look at the nodes that are running this environment, which gives us to the next tabular view, which is about kind of what is happening on these nodes. With the scale operations being happen, you can see that some of these nodes have been introduced only recently into this environment. And you can also see that if you go on these individual sets, that what we're comparing here in 3 green columns is the actual memory consumption of the node versus the actual available limit on the box that is here. So you can see it is also using 1.3 gigabytes of the available 6.8. Sort of so we're happy on this view here. What we also see when we take a look at the nodes on the right-hand side is the Kubernetes version that this environment is running on, the underlying operating system, Docker engine. You can also take a look at the labels and sort of the metadata that is involved in this node, which allows us to give an overview on what is actually happening here. We also have a tree view that allows us to drill down a little bit deeper into what pods are being scheduled on this particular node. If we want to have an assumption about what is happening here, you can also switch between the different metrics here to see and switch between those. But since there's nothing serious happening here, we sort of can be happy in this space. Now we come down to the issue of actually analyzing the underlying application set here. Thereby, we kind of want to switch back to the other cluster because we have sort of an extra prepared application that should help us here. See that the cluster or the application has prepared itself because the scale operation has happened. User pods are now being scheduled or scaled down because the user load has gone down and our cluster is now being served happily. Let's move on to the other application and take a little bit deeper look into how applications are performing. Assume in this case that we've been getting reports of our production system that it hasn't been performing that well, which is a little bit surprising because everything is green here. If we switch the view, we get an indication that might be something else happening here. What's also being done through Azure Monitor is the observation or the monitoring of the application actual behavior versus the allowed specification. So what we see here, that there seems to be some buggy application and some crashing application. And what we can see here, that the memory working set of the application has in any case a limit of 265 megabytes. The application seems to be running fine at the beginning, only consuming 50 megabytes. That seems to be increasing over time until eventually that application has been killed by the orchestrator because it was simply consuming too much. So the color indicating that this is very likely the case. In this case, actually the case, the application here did contain indeed a memory leak. For me now, the interesting part is going over to the troubleshooting guide, what was happening here. So I want to get an insight into what is happening in the application at runtime. I want to drill down into the logs that have been exhibited by this pod. What I can see here is that this was the specification. The controller is happening here. If I look at the individual container instance, I have also the option to take a look at the live logs that are being streamed towards me. Seeing this here, my application can surface a set of nodes. So I can go in here and take a look at what is happening in real time. There's also maybe another application that serves this better. Which again here, I can send a message to this application from the outside. So I just triggered another message. Let me change the text. Hi there. IKS seminar, webinar, and if I fire it up, you can see that the response or the log output is being made available from this side quite quickly. I have also the option to search live into this. So if I want to know, for example, something webinar, I can see a highlighting of all the messages that contain this, which gives me a good insight into the outputted message here, which does help me if I want to get, as a developer, insight into live logs that are now happening on the production system. The other part that might be helpful to have insight into what the application here in this case is doing. So in this case, you can see that the application is continuously consuming more memory. So there's the memory leak, and you can see what as in real time as the application is kind of pulling more and more memory and eventually crashing due to the outage here. What else do I want to do? So this was kind of the real-time view. Now I want to go back in time and see how often this has been happening. So I take my buggy app, and as you can see, there's next to the specification of the application and the live log, also the option to drill into the logs of that particular application. To do this, I'm redirected to another dashboard, which is also already creating a query specifically for this container. So it's setting using the time frame I've given in before. It has inserted the container name and the right cluster. You can see we can have multiple clusters and multiple environments, therefore we need to kind of be specific in the space. And I can also aggregate and create a set of um, rules that will be outputted here and allow me to kind of page through the days of logs that have been persisted by this application. I can also search for stuff if I have a concrete view what is happening here on the output, if that might be relevant in this case. So this gives me kind of the view of how I can formulate queries, persist them, and drill down into what is happening here. If I'm being more smart of this, I can also create queries that only surface concrete input. So in this case, I'm seeing that the schema, for example, gives me the option to ask all the container state failed messages from this buggy app, and I can count the number of container crashes in the last 10 minutes, which has an advantage because maybe I do not only want to be kind of sift through the logs, but I also want to get notified if something happens. So think about the problem. If that application crashes continuously, again, after I've implemented the fix, I want to get a notification right away, or someone should be notified right away to take another look at this, because now I think that this application might be troublesome later on. I can persist that query and also export the output. But what is also interesting here is that I can define alert rules in this space. Go in here, say, I want to use this rule. I've already added a condition for this. And want to use the crash times as a count. So let's say if the application crashes in 10 minutes more than 3 times, based on the relation period of 5 minutes, evaluated every 5 minutes, every 10 minutes, I want to get a notification. And this is kind of the next step that the Azure Monitor backend also allows me to do, is to use these log queries to define the existing new action groups. You can see what kind of the option are here. I can send me a mail. I can trigger some kind of function, a logic app, and that sends a process that can start to create an interface with my CRM system or my ITSM system. I can also simply trigger some kind of webhook and customize it right with custom code, or all of the other things that are happening here. Or I can trigger automation runbook. Think about this here. I'm triggering some kind of bash or PowerShell script that will kind of expand the cluster or change configuration rules in here, depending on the problem that might be happening here. We're not going to do this for now, but the important part kind of being there is an option to kind of not only use the log message in retrospect, but also use logs to trigger events that might be more relevant in the space and share this with additional teams. What might be also interesting is to create some kind of chart in here. So in this case, I want to have an overview of how many times that application has been crashing, which in this case is a little bit of a boring chart, but you can imagine that you can, based on the queries that are available and the schema as you can see on the left-hand side, you can create pretty interesting queries, and also use these queries to share them with the bigger team. Think about here, turning this graphic into a dashboard, which can be shared with a set of teams. So think about this can be something like my, take a little time to load. Think about this is my operational dashboard, which I will be using and serving to my operations team, which can kind of configure and drill down not only the metrics and the logs and the graphs from my Kubernetes infrastructure, but also maybe from my network, storage, from various other parts of the application into a bigger holistic view of what is happening here. I can share this with everybody who has an Azure AD account in my environment, and also give different permissions on this to make sure that this overview is being available by everybody. You might not always give everybody the same permission to access the actual infrastructure, but I think but it makes a lot of sense to give people the overview onto the logs and at least the dashboards that are servicing these infrastructures. Coming back to the environment, let's drill down back again to the cluster. There are a couple of additional points that might be interesting here as well, other than looking onto these environments. You also have the option to surface here the metrics. The logs, as I showed you, are accessible in here, to give you kind of an overview of what is happening here. The other interesting part is kind of sort of schema. So what kind of properties of each of these messages is available for filtering or creating queries. As you can see, there is sort of a large set of stuff that is available. There's kind of text, and there's numbers, there's date time queries, and all of these can be used in different kind of query format to narrow down your assumption on what is happening in the environment, validating this, and also having an overview reactively on what is happening there. Other operational aspect that might be interesting in this space is that you might not only be interested in your own application, but also in the backend. AKS in this sense is a managed environment, which means you sort of do not have actually access to the master nodes that are running this. But you still might be interested in kind of the scheduler logs or an audit log that gives you an overview of what's happening in your environment. This is sort of a little bit hidden, and you have to know that if you click on the resource group that is in this case containing your Kubernetes cluster, you can click on diagnostic settings. In the diagnostic settings, you now have the option to turn on diagnostic logging. And in this diagnostic logging, you have kind of the option to also include the Kube API server, the controller manager, the autoscaler, the scheduler, and also the audit logs, and forward all these logs into the same log analytics space, meaning the same space where you can query, monitor, and alert dashboards and alert rules from in one space. Something else that might be interesting is kind of how you configure all of this into an existing environment. In an AKS, this is kind of in the user interface, a very simple view in how you can spin up an environment, get asked a couple of questions, and in the monitoring space, simply leave kind of switch the yes default space. You can service multiple Kubernetes clusters into the same log analytics workspace, which makes a lot of sense if these applications are tied together logically, and that you can compare the logs across these different clusters, or you can spin up an individual workspace for one cluster and separate them. There's also the option to create these things declaratively. So in this case, kind of see from the naming convention, I've created all these infrastructure artifacts by using Terraform. And this is kind of next to a native Azure Resource Manager templates, also kind of the option to kind of make sure that when you're spinning up an infrastructure, it has kind of networking, the log analytics space, the Kubernetes cluster, storage accounts, and all the other resources that are used by application, all defined in one template that you can roll out consistently across different environments, make sure that they're all configured in the same way and not in kind of unicorn way different. That was a little bit the overview, kind of. So the point being that we want to make it very easy for you to spin up a Kubernetes cluster, attach a solution for monitoring workloads that doesn't cost you very much, because it's only doesn't have any infrastructure cost, only the kind of the storage that in which you're persisting the logs, and make that available as a managed service that will be upgraded by Microsoft in your cluster. Having hopefully addressed all these points, go a little bit deeper to the bigger picture here. We showed you a little bit that we want to make it available as a cross-tenant solution. So think about having an Azure tenant that is many subscriptions, that has many subscriptions with different resources running different applications. There's a sort of a high stack of stuff that you want to monitor and have a drill down view. Not only the containerized context, but also the other resources that are being used. Think about the databases, the storage accounts, the network pieces that are being used to make this work. It also has an integration point into the processes that deploy applications. So in this case, you might have heard of Azure DevOps, which is sort of our solution for bringing applications into your environments and making sure that all these things are available, giving you insights into the application, having different visualization forms, as we showed you in the dashboards, to have a drill to see what is happening across all the different artifacts and resources that you have provisioned, giving you tools to analyze what is happening here. Think about the metrics and the log space that we've shown you. Also triggering automated responding events on resources that have been doing. Think about application, the stuff that we've shown you. Application crashes 3 times. I want to first of all notify somebody, but then maybe want to also trigger an automated response reacting on this, and also integrating this into different line of processes that you might already have in place. In this case, something like an IT management system that you want to notify for each error message, so that someone can take a look at it later and understand what is happening there. Being this the bigger picture of Azure, how Azure Monitor fits, first of all, into your Azure environment, but also into how you manage your processes inside your enterprise. Yeah, the onboarding experience is actually quite fast. I've shown you in the user interface. There is also the option to persist and deploy this by using Terraform. If you want to do this, is actually not that complicated, but also kind of the option being that you can spin this up by using interactive mode inside that cluster. The other option is obviously kind of you can do this by using Terraform and declaratively and configuring this in your own environment. Control logs is something that we showed you already. That is obviously, I showed you how to activate this. This is how you can formulate a query against the diagnostic log that is containing the master logs, which is particularly interesting if you think that there's something wrong that is not directly related to your application, but rather to how the cluster operates, giving you the option to figure out if it's a developer problem or an orchestrator operations problem that you might need to solve by including somebody else. To close up, I want to give you a couple of follow-up resources. First of all, kind of additional documentation on how you bring on learn AKS in Azure. There are a couple of learning seminars that give you more details on the different insights. And we obviously also want to give you insights on how you can bring Azure Monitor into your Kubernetes environment running in Azure. Thank you very much. Hope you enjoyed this and able to implement what you've seen here today. We're looking forward to having you on a different seminar on a different subject. So